In 1942, the scientific community was thrown on its head when Raymond Dart, an Australian anatomist and paleontologist, made a groundbreaking discovery in Taung, South Africa. Unlike most discoveries that involved immense experiments and even more outlandish theories, Raymond's discovery was rather small, but its implication would change the course of history quite literally. Raymond received the fossilized skull of a young child from a limestone quarry worker named Joseph Motletle. This fossil wasn't your average child skull and would come to be known as the Taung Child or Taung baby. It belonged to a never-before-known species, later named Australopithecus africanus. But what was Australopithecus? Why were they important? Who is Lucy? And how did the discovery of a single, complete fossil change the timeline of the world's history? Australopithecus is a genus of extinct hominids that lived in Africa from about 4.2 to 1.2 million years ago. Considered to be one of the earliest hominin or human-like primates, these creatures were characterized by a combination of ape-like and human-like features. These included having a small brain size, projecting faces, large jaws with powerful chewing muscles, and, to the shock of the whole science community, the ability to walk upright on two legs, bipedalism. Compared to the average human, these creatures had relatively long arms and fingers, a trait they most likely kept from their ancestors, who just a few million years ago still swung from tree to tree. Since Raymond discovered the Taung Child, hundreds of sites across Eastern Africa and South Africa's Sterkfontein and Makapansgat caves have unearthed numerous fossils representing several unique species of Australopithecus. These caves are now renowned sites for the study of early hominins. However, the fossils discovered at Sterkfontein were not just important for anatomical studies, but also presented an additional twist, as multiple species of Australopithecus were found within them. These species included Australopithecus africanus and Australopithecus robustus. However, the caves weren't the only source of scientific breakthrough, as in 1974, the famous Lucy fossil, an Australopithecus afarensis specimen, was discovered in Ethiopia by Donald Johansen and Tom Gray. Found in the Afar region of Ethiopia, in a site known as the Hada Formation, Lucy is one of the most complete Australopithecus skeletons ever found, and was an instant scientific breakthrough, as she gave us detailed insight into the early hominins' locomotion and anatomy. When it comes to anatomy, the Australopithecus, which by the way means southern ape, is quite a fascinating species, as it blends both ape-like features and somewhat human features. According to research and fossil records, the Australopithecus was small and slender, typically between 1.2 and 1.4 meters tall. The same study also found that there was probably a difference in size between males and females, with males possibly being up to 50% larger than females. However, not everyone believes this, as scientists today are not entirely sure, because most of the fossil evidence available is incomplete. According to researcher A. Zillman, there was a physical likeness between Australopithecus and bonobos, an endangered species of pygmy chimpanzee found mainly in Africa. His research suggested that the Australopithecus had similar body proportions and size to the bonobos. However, the similarities don't stop there. Additional models of how the Australopithecus regulated body temperature indicated that they likely had abundant body hair, similar to chimpanzees and bonobos. This hair would have aided the Australopithecus in maintaining a stable body temperature, unlike modern humans, who typically have less body hair and rely on other methods for thermoregulation. Much like today's humans, the Australopithecus had 32 teeth, with their teeth being a mix of old and new features. But perhaps the strangest thing about the species' dentition is how unique it is. See, their canines were smaller and less connected, more like ours, and they had 4 low rounded bumps called cusps for crushing food, similar to ours. However, their molars were also parallel, like those of great apes, and they often had thicker enamel compared to other apes. To make things more unique, their teeth were stronger than other apes, with some species having very worn-down back teeth. So, what did they use these teeth to eat? According to research, the Australopithecus species likely had a varied diet, mainly consisting of fruits, vegetables, and tubers like yams. However, that might not have been all they ate, as new evidence claims that the ancient apes may have also easy-to-catch animals, like small lizards. Besides this, some studies suggest that some Australopithecus species may have consumed meat occasionally. This is primarily because they had larger front teeth, indicating they might have needed them for tearing food, perhaps even scavenging meat, though most evidence points to a primarily plant-based diet. Besides their teeth, their body shapes, which included their large bellies and the position of their sagittal crest, further support the idea that they were adapted to a diet rich in plant food, with their front teeth processing most of the food they eat. Besides having a diet and dentition that bore an eerie resemblance to ours today, the Australopithecus also had a trait that baffled scientists for years to come, and it all boiled down to how they moved around. When it comes to getting around, the Australopithecus took the entire science world by storm, and this was all due to one of the greatest archaeological discoveries ever, the Laetoli footprints. Discovered in 1978 by a team led by paleontologist Mary Leakey, the Laetoli footprints are a set of fossilized footprints discovered in Tanzania, East Africa, dating back approximately 3.6 million years. Left behind by Australopithecus, the footprints were found preserved in volcanic ash deposits at the Laetoli site. The site itself is located near the Olduvai Gorge, a renowned paleoanthropological area rich in hominin fossils. These footprints were all the rage in the scientific community, as they offered a fascinating glimpse into the past, providing tangible evidence that Australopithecus walked on two legs, an essential milestone in the story of human evolution. But why was this such a huge deal? Well, a majority of the controversy surrounding this finding came from conflicting evidence and interpretations in early hominin evolution. See, initially it was thought that large brains preceded bipedalism, but discoveries like Australopithecus fossils with small brains challenged this idea. Essentially, scientists were left to debate whether bipedalism was an adaptation to specific environments or inherited from common ancestors. Besides the major controversies surrounding the footprint discovery, the setting for the discovery itself was equally intriguing. See, after a volcanic eruption millions of years ago, the ground was covered in ash. Following the eruption, there was rainfall that not only marked the land, but also mixed the ash into a slurry. It was in this unique combination of volcanic residue and rain-formed indentations that the Australopithecus ventured, leaving behind a trail of footprints that would endure for millions of years, giving us clues about how Australopithecus moved. Moving forward, the examination of these footprints reveals a striking similarity to our own. This is because when Australopithecus walked, their heels made initial contact with the ground, followed by the rest of the foot. As such, the deep imprints from their big toes showed they pushed off strongly with each step, and the arches in their feet helped them move efficiently. The ability to walk with 2 feet was a game changer for these ancient apes, as scientists think it gave them some advantages, such as freeing up their hands so they could carry things or babies while walking. Also, standing tall may have helped them see over tall grass and spot food or dangers ahead. However, the transition to bipedalism was not without its challenges. Compared to their quadrupedal counterparts, the Australopithecus may have been slower in their movements, and the adoption of an upright posture may have placed additional strain on their bodies, potentially leading to issues such as back pain or other musculoskeletal problems, much like those of an elderly person today. With key sites located in the Great Rift Valley, South African caves, and the Chad Basin, the Australopithecus species presents itself as one of the most fascinating, as across different species they exhibit variation in morphology and behavior, reflecting adaptations to different environments and lifestyles. In fact, some lineages, such as robust Australopithecans, show cranial facial adaptations for processing a vegetarian diet, while others exhibit tooth reduction, brain expansion, and even the use of tools. In addition to the anatomical variation, Australopithecus species likely exhibited diverse behavioral adaptations in response to their respective environments. In fact, the presence of stone tools associated with some Australopithecus fossils actually suggests an early capacity for tool manufacture and use. These tools may have been used for processing plant foods, accessing animal carcasses, or even for defense against predators. But regardless of their use, the variability to use tools was a discovery that left researchers around the world confused and excited, especially when you consider the fact that the ecological diversity of Australopithecus is reflected in their geographic distribution and habitat preferences. Essentially, fossil finds indicate that Australopithecus species inhabited a range of environments, including woodlands, grasslands, and even more open savanna habitats. This ecological flexibility and their ability to use tools were also a pointer to a much bigger discovery. The Australopithecus was evolving into a Homo, the genus of the modern human. As a hallmark of the transition, the development of more sophisticated tool use and technological innovation was revolutionary. While Australopithecus species utilized simple, stone tools, early Homo species showed evidence of more refined tool-making techniques and the use of diverse tool types for various purposes. Essentially, we can see the tools getting more sophisticated as the apes evolved. But there's more, as this change was also biological. The transition from Australopithecus to Homo was not a sudden event, but rather a gradual process, spanning millions of years. Fossil discoveries, such as those of Australopithecus afarensis, show intermediate features that bridge the gap between Australopithecus and Homo. For example, Australopithecus afarensis exhibits bipedal locomotion, similar to later Homo species, suggesting an early stage in the evolution of our genus. But by far the biggest evidence of this transition is the morphological changes observed in the fossil record. These changes include increases in brain size, alterations in tooth morphology, and shifts in body proportions. For instance, compared to Australopithecus, early Homo species exhibit larger brains relative to body size, reflecting an expansion in cognitive capacity and possibly the emergence of more complex social behaviors. But that's not all, as changes in tooth morphology, such as reductions in tooth size and robustness, suggest shifts in dietary patterns and food processing techniques. Although complex, these adaptations may have been driven by changes in habitat, resource availability, or social dynamics, indicating the evolutionary flexibility of early Homo populations. Another confounding sign of the evolutionary flexibility of the Australopithecus is a trait found in their kids, a trait that very closely mirrors that of today's babies. See, the Australopithecus, much like many early hominins, exhibited a unique pattern of brain development. And one significant aspect of this development was the slow growth of the brain during childhood. This was very strange, as unlike some other primates whose brains grow rapidly during infancy, the Australopithecus brain showed a slower pace of growth. This slower growth is quite important, as it is believed to reflect a prolonged period of learning and cognitive development during childhood. Essentially, this pattern suggests that Australopithecus infants had a greater capacity for learning and adapting to their environment as they grew. It meant their brains had more time to absorb information, acquire skills, and develop cognitive abilities essential for survival in their environment. As such, this prolonged period of brain growth likely contributed to their ability to navigate complex social dynamics, acquire tool-making skills, and adapt to changing environmental conditions. But that's not all, as the Australopithecus kids bear more resemblance to today's kids. Research has also shown that the Australopithecus babies likely had larger eyes and heads compared to adults. It is believed that this aided in learning and social interaction. But that's not all, because like the younger kids of today, they also had increased joint flexibility, which would have been great for exploration. However, as they grew, their joints grew too, becoming specialized for upright walking, leading to a loss of early flexibility. Acting as the proverbial Bigfoot of the human evolution tree, Australopithecus is a treasure trove for researchers worldwide, as this long extinct ape continues to bridge the gap in our environmental knowledge, pushing the boundaries of what we know. However, not everyone believes these ancient apes to be part of our ancient family tree, as many researchers claim the fossil record and genetic evidence suggest that Australopithecus is not a direct ancestor of modern humans, but rather a close relative that inhabited Africa alongside early Homo species. But what do you think? Is Australopithecus a completely different species from us, or is it the missing link in the evolution of today's humans? Let us know in the comment section below. And while you're at it, make sure to leave a like and subscribe to the channel for more prehistoric knowledge. Until next time, stay curious.